As young planets grow, the changing gravitational interactions between them can eject material and even whole planets from the system, condemning them to wander the dark and cold reaches of interstellar space. When we think of planets, it's the stable and orderly layout of our own solar system that comes to mind. Indeed, this is the end product of planetary formation that hides its violent and chaotic beginnings. As young planets grow, the changing gravitational interactions between them can eject material and even whole planets from the system, condemning them to wander the dark and cold reaches of interstellar space. In fact, recent observations have shown that such objects are actually quite common. Some studies suggest there may be up to 100,000 more rogue planets than there are stars in our galaxy, making planetary systems the exception rather than the norm. In addition to system ejection, some rogue planets may never have been part of a planetary system at all, but are simply the low end of the same process that produces stars where there simply wasn't enough material to form a body large enough to undergo nuclear fusion. Lone planets 10 times the mass of Jupiter and smaller, possibly as small as our own Earth, can be formed this way. Now you might think that rogue planets are dead, frozen worlds, and no doubt some are, but there are ways to generate heat that doesn't involve a star. If the planet has a thick enough atmosphere, radioactive decay can heat even an Earth-sized planet so that liquid water can exist on the surface. Gas giant planets also generate heat through the pressure of their own mass, resulting in temperate layers within. Jupiter, in our own solar system, generates more heat than it receives from the Sun through this process. If a planet is ejected with a large moon, the tidal forces between the two bodies will generate heat. This process is responsible for the deep, ice-covered liquid oceans found on moons in our own solar system, such as Europa. In addition to planets and moons, small objects such as comets and asteroids can be ejected into deep space. Recently, astronomers have identified objects that have entered our own solar system from these distant systems. In October of 2017, the Pan-STARRS 1 telescope in Hawaii sighted an object traveling through our solar system at 196,000 miles per hour, far too fast to be gravitationally bound to the Sun. Observations suggest this unusual object had been wandering through the Milky Way unattached to any star system for hundreds of millions of years before its chance encounter with our solar system. In August of 2019, amateur astronomer Gennady Borisov discovered a comet that was found to be moving at a speed in excess of 100,000 miles per hour, again far too fast to be gravitationally bound to the Sun. Astronomers are just now learning how to look for these visitors from interstellar space, which it turns out seem to be surprisingly common. It seems that making suns and solar systems is a messy process, filling the space between the stars with objects of all sizes, from hot massive gas giants to tiny comets. These wandering worlds have a fascinating story to tell of events around other stars far away and long ago.